Yeah, they tried to rig the game, but you can't fake influence.
Think it on it like that.
Hey, I'm tripping, I'm sliding, I'm riding through the back like fuck. Mustard on a beat, bro, deep bird, any rap, he a freak though. Man down, call like ambulance, tell him breathe. Let them boys to the cross, they walk around like G's. What's up with these Draconio? Trying to see Compton. In the street can hate me, bump them all in they mama. How many options you really got? I mean, it's too many options. Been a crash on his body, I'm John Stockton. What? Beat your and hide the Bible if God watching. Sometimes you gotta pop out and show.
Good day, good day, good day. Welcome to our YouTube channel. So if you're new here, my name is Stiffler and I'm the one who's going to be teaching you throughout if you decide to be part of our YouTube channel, right? So if you want to be part of our YouTube channel, please subscribe and also share this with your mates. I'm sure they will also love to enjoy this content that we create over here. So last time we talked about organic chemistry, but I was just doing the introduction to organic chemistry. I will place the link here so that you can watch it if you haven't watched this, right? So today we are going to explore more about this organic chemistry, and you'll be able to answer all the questions that you need or all the questions that you'll be given on organic chemistry. So organic chemistry, I'm going to divide it into three parts. Which the first part is about naming, identifying, drawing, as well as isomers. So the first part will be about these things. And then the second part, we are going to be talking about intermolecular forces. We are going to be talking about boiling and melting points, as well as vapor pressure. And the last part, we'll be talking about the reactions, the chemical reactions. So this is the chemical properties. So this is the physical properties and the chemical properties. So we can now begin on our part 1. I hope you enjoyed this, guys. I would also love you to enjoy this. So in our previous video, I already explained these two concepts, right? I've already explained them. If you can, please go and rewatch the previous video that we made and come back to this one, because in the previous video we really explained some more stuff that are really important before you can get on organic chemistry. But nevertheless, let me re-explain this concept. So we are having the functional group. We say the functional group is an atom or a group of atoms that forms the center of chemical activity in a molecule. That's the functional group. An atom or a group of atoms that forms the center of chemical activity in the molecule. And then homologous series we explained by saying this is a series of similar compounds. Which have the same functional group. And their members differ by CH2. Their consecutive members differ by CH2, and also said they have the same general formula. So today we are just going to start here and explain these, right? So the homologous series that we're going to focus on with these caps, it is the first one we're going to deal with alkanes. So on alkanes we are going to learn how to draw, how to name, as well as the molecular formulas and identifying, right? And also going to deal with alkenes, alkynes, and also going to deal with alkyl, halides, or we call this also halo alkanes, and also going to deal with ketones. We're also going to deal with aldehydes and also alcohols and also carboxylic acids, and lastly we are going to deal with esters. So all these, after this part 1, you must be able to identify each and every of these. You're also supposed to be able to name each of these compounds, and also draw each and every compound, and also know their functional group. So pay a closer mind to all of these, right? So you must be able to do all 4 of these on these compounds. So we are just going to start with the alkanes and the branched alkanes. I hope you're going to have a good time. Let's enjoy this. So alkanes, we are on alkanes. So what are alkanes? So alkanes, they are hydrocarbons. So these are hydrocarbons that have single bonds. They have single bonds between their carbon atoms. And when this situation is like that, we call them saturated. So it means that these are saturated hydrocarbons. Saturated hydrocarbons. So they have only single bonds between their carbon atoms. So the functional group now, the functional group of alkanes, it is this. So this shows that there are single bonds between the carbon atoms, right? So that's the functional group. So every time that they ask you what is the functional group of alkanes, this is the functional group. So this is the structural formula of the functional group. So this is the structural formula of alkanes. And then the general formula of alkanes, it is just simply CnH2n plus 2. So this general formula helps us when we know how many carbons are in the compound, but we don't know how many hydrogen atoms. So if we know that there are 5 carbons in the compound, so this will be C5, and then H2 multiplied by 5 plus 2. So it means that this is C5H12 as our molecular formula. Remember last time we talked about the molecular formula, we said it is just the representation of how many of each atoms are in the compound, irregardless of how they are arranged in the structural formula, right? So this is the general formula of these hydrocarbons, right? The alkanes. So from here we are going to learn how to name these hydrocarbons. How to name. Take your time on this, on how to name this, because it is very, very important for you to be able to move around these hydrocarbons. You need to understand how to name the alkanes first, mostly the branched alkanes. So let's get straight to naming the alkanes before the branched alkanes. So how do we name the alkanes? So naming the alkanes is determined by how many carbons are in the main chain. So if we know how many carbons are in the main chain, it becomes simple to name the alkanes. So when naming the alkanes, we use the prefix and use the suffix, right? So just take it as you and in your family, you are having your name and also your, so this will be your name, and you also have the surname, right? So you share the same surname with the siblings, so it means that also the alkanes, they share the same suffix but just different prefix. So the suffix that we use in alkanes is A-N-E. So A-N-E, this is the suffix of the alkanes. And the prefix, as we said, the prefix is determined by how many carbons are in the main chain. So if we're having one carbon in the main chain, we use the prefix meth. If we're having two, we use F or if, right? Depends on your pronunciation. And then the third, if you're having three, this is prop. If you're having 4 carbons, then that's put. If you're having 5, that's pent. If you're having 6, that's hex. If you're having 7, that's hept. If you're having 8, that's oct. So this acts as the what? As the prefix. These are all the prefix. So let's take a look at these examples if you're having this now. So if you're having this hydrocarbon drawn like this, so how can we name these now? So we can count the number of carbons that are in the compound. So we're having 1, 2, 3 carbons. So the prefix of 3 carbons is prop. So we are going to name this prop. And alkanes always have the suffix ane. So we're going to include ane in that. So the name of this compound will be propane. Propane. This being the prefix, this being the suffix. So also the suffix shows us that this falls under what? Under alkanes, because that's the homologous series to which the ane belongs to. So this is how we can name the alkanes. Maybe you can try this out, or maybe let me do this one more and then you can try some other ones, right? So if we're having this compound now, so this is having how many carbons? You can see that these are 6 carbons, right? So 1, 2, 3, 4, 5, 6 carbons, right? So with 6 carbons, let's check the prefix. The prefix is hex, right? So if the prefix is hex and the suffix is already given, which is ane, so we're just going to say hex plus that ane, that gives us hexane. So that is hexane right there, right? So maybe you can also try this out. So can you try out this one using the same procedure that we're using? So you can pause the video for now and work on it, and then I can give you the answer afterwards. So 3, 2, 1, go. Okay, so naming this, it means that you can start counting the carbon atoms. So we're having 1, 2, 3, 4, 5, 6, 7. So the prefix here, it is hept, and you can add the suffix, so this will be heptane. So this is heptane, so that is the heptane, right? So I'm sure you are able to name these alkanes so simply, just like that, right? So now let's move to branched alkanes, which are a bit complex, but trust me, with practice it will be simple. So now we can move to branched alkanes. So how do we name branched alkanes? As you can see that this compound that we are working with right now is different from the ones we were working on previously, right? So we can see that here there is a branch like that. So how to name the branched alkanes? It is simple. Let's get to this bit by bit. I'm going to give you rules that you can apply to be able to name this. So let's get to the rules that you can use. So the first rule that you can use before getting to this, the first thing is to identify your longest chain. Identify your longest chain. So let me just place it as identify your longest chain, or we call this the parent chain. So this is the parent chain that you have to identify. So how can you identify the longest or the parent chain? You first check the carbons that are having 3 hydrogens. So you check the carbons having, so you check the carbons having 3 hydrogen. So that's your starting point, to check the carbons that are having 3 hydrogens. So if you can check in this compound, you're having, this is having 3 hydrogens, this is having 3 hydrogens, and also this is having 3 hydrogens, right? So you can start from any that is having 3 hydrogens to the other one that is having 3 hydrogens, right? So we are going to start to count from here and end there, or and end there, right? But the longest one will be our parent chain. So if we start from here, it will be 1, 2, 3. So if we start here and end there, it is 3 carbons. If we start there and end there, let's see, 1, 2, 3, 4. So if we start here, we are going to have 4 carbons in the longest chain. If we start there, we can have 1, 2, 3, 4, or we can have 1, 2, 3, 4. So now it is, we can be confident that our longest chain is having 4 carbons, right? Our longest chain, we have 4 carbons. So what do we do next now? It means that now, since we have seen that our longest chain is having 4 carbons, it means that we can say, according to the previous work, it means that this is supposed to be a butane, right? It is a butane. The longest chain, it is a butane, right? Now, let's check the chain. So now, after identifying the parent chain, now you number your carbon atoms from the side that is closest to the branch. We start from the side closest to the branch, right? So let's see. So it means that if we start from this side, to count from this side, this will be our carbon number 1, our carbon number 2, our carbon number 3, our carbon number 4, right? So the branch is coming on carbon number 2 there. You can see that this is where the branch is coming at, right? If we can start to count from this side, it will be 1, 2, 3. So it will be on carbon number 3. But they said we must start to count the carbon atoms from the side closest to the branch. So the branch is actually closest to this side. So it's 1, 2. So it's coming on carbon number 2. So we can now write that our branch is coming on carbon number 2, right? And the next thing now, it is this branch. You count how many carbons are in the branch. That's the third thing. So we are going to count number of carbons in the branch. So here you can see that there's only one carbon in the branch. So if it's only one carbon in the branch, we're still using those names we're using on naming alkanes. So we said with 1 it's meth, right? With 2 is eth, and then with 3 is prop, right? But now we are no longer using the suffix a and e. Now we are going to use, if this branch is having one carbon like that, so this will become methyl. So we add L and Y. So if the branch is having 2 carbon atoms, we call it ethyl. If it is having 3, we call it propyl, like that. You see, so now we are adding Ly. So we said this branch is coming on carbon number 2, and it's only one carbon in that branch. So this definitely has to be a methyl, like that. Can you see that? So what's the next thing now? Now we can put this whole thing together now. So according to this one, it is a simple one. It's going to be just okay, maybe let's just finish all the rules all at once, and then we can name this, right? So after counting the number of carbons in the branch, now we check if you are having 2 or more branches. To name these branches, or to put these names in the branches, it means that we are going to start with the one that comes first alphabetically, right? So we're going to start with the one that comes first alphabetically. As you can see, ethyl comes first, then methyl comes second, then propyl comes third. If we are having a situation that we're having 2 branches, right, in the name, so it means that we can start with ethyl, then methyl, then propyl. So E comes before M, and M also comes before P. And the next thing that you have to do as well is, if now, let me just write the 5th rule there, right? So as well, if you are having 2 or more of the same branches, right? So if you're having 2 or more branches with the same name. For example, if you're having 2 of these methyl branches in the same compound, it means that now we are going to start including the names like di, tri, or tetra, depending on how many we are having. So if we are only having 2, it means that we are going to include this di before including the branch that is coming more than once, right? If it is methyl, then we are going to say dimethyl. If it is 3, then it is trimethyl, just like that, right? And lastly, so here, as you can see, we are including the numbers and the letters when writing this, right? So between numbers, always use a comma. So we are going to include a comma between numbers. We are going to see that as we go further, right? And between a number and a letter, we are going to use a hyphen. We are just going to use a hyphen like that between numbers and letters, right? We are going to use a hyphen. So now let's include this and make the name for our compound. So it means that we said this is butane and it is coming, we're having a group of methyl or a branch of methyl which is coming on carbon number 2. So the name of this simply becomes 2 and then hyphen, because now we are going to include a letter, so it's methyl, and then this parent chain is a butane, so methyl butane, like that. So that's how we can name this. Maybe let me rewrite these rules in a nice way so that you can copy them down and we can use them on the next question. So this is a full list of all the rules that you can use to name these branched alkanes, right? So if you are closer to the book and a pen, you can write these rules down and then we can explain them step by step using a question. And if you are far from a pen and a book, you can screenshot this and then you can use it later. And then, so we said the first one is identify the longest chain, which you call the parent chain. And already I've explained that the way that you can identify which one is the longest chain, you check the carbon atoms that are having 3 hydrogens. So that are having 3 hydrogens, right? So after identifying these that are having 3 hydrogens, you can do a try and error, moving from one side to the other, moving to the other, and checking which one gives you the longest chain, which one gives you the highest number of carbon atoms in the chain. So that's the first step, right? So you check your carbon atoms that are having 3 hydrogens, and then from there you just follow them through inside the what? The chain, and then you check which one gives you the longest chain or the highest number of carbon atoms. Now after doing this, you can name it using the previous rules we were using when we were naming the alkanes. If the longest is having 7 carbon atoms, then it is a heptane. Then you can write that down. So if it's a heptane, you can just write it as a heptane, like that. The second step, so after you have identified your longest chain, right? So it means that there are some chains, or it means that there is some of the hydrogens with 3 hydrogens that are not in your longest chains. So there are some of the carbons that are having 3 hydrogens that won't be in your longest chains. So you identify that and then you check those branches, right? Identify the branches, right? So you identify the branches and you name those branches. Like I said, if your branch is having 1 carbon, so it will be a methyl. If it is having 2, then it will be a ethyl. 3, it will be a propyl, like that, right? I've already explained that. And then you number the carbon atoms in the parent chain, in the longest chain, right? Starting from the side that is closest to the branch. So the side that is closest to the branch, you can first start from the numbering, right? So if 2 or more branches are having the same number from opposite sides. So for example, if you're having this longest chain that is like that from that side to this side. So if you're having a branch coming on carbon number 2 here, and also a branch coming on carbon number 2 if you count from that side, so it means that these branches are having the same position from opposite sides, right? From opposite sides or opposite ends. Give the one that comes first alphabetically the lowest number. For an example, if you're having a methyl here, so if you're having a methyl here and you're having an ethyl there, right? So it is wise to give this one that comes first alphabetically the lowest number. So it means that we are going to start counting from that side instead of this side, because E comes before M, just like that, right? And then the next thing is if the same type of branch occurs more than once, we use the suffix di, tri, or tetra, right? So it means that if we're having two of these methyl groups, we can just say dimethyl, right? Dimethyl. If it is three, trimethyl, and so on, right? So now put down the names of the branches first with their numbers. So we write the branches first with their numbers, starting with the one that occurs first, or that comes first alphabetically, right, with their numbers. And now we can write the parent number last, right? But always remember that between numbers we put a comma, right? Between numbers we put a comma, and between a number and a letter we put a hyphen. So I hope you screenshotted this, or you wrote this down on a piece of paper, and we can start to solve some of the questions while you are looking at these rules, right? Enjoy this. So let's try to name this using the rules, right? Like I said, the first thing is to identify the longest chain. So I said how to identify that. We first check all the carbons that are having 3 hydrogens. So this is having 3 hydrogens. Also this is having 3 hydrogens. Also this is having 3 hydrogens, 3 hydrogens, 3 hydrogens, right? So I said we do a try and error, just trying to check which one will give you the longest number of carbons in the chain. So we're going to have from this 1, 2, 3, 4, 5, 6, 7. So this is giving us 7 carbons in the longest chain. So let's see this 1, 2, 3, 4, 5, 6, 7. Also, if you go like this, it will give us 7. So from here 1, 2, 3, 4, 5, 6, 7. But also you have to be careful. We cannot go this way, leaving this way that is also having a branch. So everywhere that you take, you must not have a branch of a branch, right? So it means that this one you can cancel it, and also this one you can cancel it, because this side we are having a branch as well, right? So this will be our longest chain from 1, 2, 3, 4, 5, 6, and 7. So after identifying the longest chain, I said you name it. So the longest chain is giving me a heptane. Said 7 carbons is a heptane, right? The next step, now we number our carbons. So it means that this is our longest chain from here to here. So it means that this, and that will become the branches now, right? So now we are going to number our carbon atoms from the side closest to the branch. So obviously this is the side that is closest to the branch. So this will be 1, 2, 3, 4, 5, 6, 7, right? Now we identify our branches, giving them the numbers, right? So here at this number 2, we are having a branch of a methyl. And also on carbon number 3, we're having another methyl, as you can see there. So on carbon number 3, we're having a methyl as well. And on carbon number 3, we're having 1, 2, ethyl. So on carbon number 3, we're having ethyl as well. Can you see that? So now, how can we put this together to form one name that is called the IUPAC name? So let's revise our rules, right? So on the rules, we can see that these are the names that we have as branches, and we said we can start with the one that comes first alphabetically, right? So E comes before M. So it means that on carbon number 3, we are having an ethyl. So when naming, remember that between numbers and letters we put a hyphen. Don't forget that, right? So on carbon number 3, we are having an ethyl, and on carbon number 2, so can you see that we also included in hyphen here? So on carbon number 2 and carbon number 3, so between numbers we put comma. So on carbon number 2 and carbon number 3, we are having methyl group. But if we're having methyl group, there are 2. So we include di. Dimethyl. So di is representing that we're having 2. So dimethyl. And lastly, we include the parent name now. So heptane. So it means that this whole compound is called 3-ethyl 2,2-dimethyl heptane, just like that, right? So simple, né? So let's try again another one and see how you can do this, right? So let's get to this one as well, right? So the first step, like always, we check which hydrogens, which carbons are having 3 hydrogens, right? Which ones are having 3 of the hydrogens. So this one is having 3 hydrogens, this one is having 3 hydrogens, this one is having 3 hydrogens, and lastly this one's having 3 hydrogens, right? So the rest, they're just having 2 hydrogens. So we are going to count, doing try and error, to see which one will give us the longest chain. So let's see, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So either way, this way or that way can be our longest chain. So we can now remove that. So from this side and this side is our longest chain. So 6 carbons, so that's a hexane, right? Now we go to the branches. So it means that this is a branch, that is a branch, right? So what we do, we number the carbon atoms in the longest chain from the side that is closest to the branch, right? So if we number from this side, it will be 1, 2, 3. This is coming on carbon number 3, 4, 5, 6. And also 1, 2, 3. So the branches from either side are coming at the same carbon, right? So now what do we do? Now we decide which one comes first between this branch and this branch. So let's name these branches. So this branch is a methyl because it is having 1 carbon, and this one is having 2 carbons, so it's a ethyl. So which one comes first alphabetically? It is E, right? So we are going to number from this side. So 1, 2, 3, 4, 5, 6, right? So on carbon number 3, an ethyl comes. So on 3 hyphen ethyl hyphen, and also on carbon number 4, a methyl comes. So 4 methyl, and the longest chain is the hexane. So it means that this compound of ours is 3 ethyl 4 methyl hexane, just like that. Maybe let's do one more example before I can leave you with something to try on, right? So let's do this last one. Let's see how it goes. So I said first we identify the longest chain. We can do this by identifying which carbon is having 3 hydrogens. So we're having this, this, and that, right? So let's see how this goes. We first do try and error to see which one is having the longest carbons in the chain. So 1, 2, 3, 4, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So it means that this is the longest chain, like that, because it is having the longest carbon atoms, right? So 6, it is a hexane. And then now we can do like that, like that. Now we are knowing which one are our branches. So let's see these branches. This is a methyl, because it is having one carbon. This is also a methyl, it is having one carbon. So we're having two of the methyls, right? So we check now the positions where they are from different ends. So 1, 2, 3, 4, 5, 6. So this one is coming on carbon number 3, and then from that side it's also 1, 2, 3, 4. So now it means that we can number from any side, it's fine. So 1, 2, 3, 4, 5, then 6. Now we can put the name together. So it means that we are going to have on carbon number 3 we are having a methyl, on carbon number 4 we are going to have a methyl as well. So this is going to be 3, 4, and then dimethyl, because there are two, right? Dimethyl, and then the name is hexane, dimethyl hexane. This is how we name the branched alkanes. I hope you enjoyed this section with me. I really enjoyed. So again, don't forget, please subscribe to our channel and also share with your mates that would like to learn as much as you do. I will see you on the next one. We will be discussing alkenes and alkynes, but I will leave you with the work to do right now. Have a lovely day and enjoy your week.